Hello everyone and welcome to our YouTube channel. We are working on a series of videos on openmp. This is the second video on the series, and in this we will be studying static scheduling. Okay, so before going to the scheduling part, let's learn what is a construct. So in this slide, as you can see, I have written the for construct. But before going to for construct, let's just understand what a construct is. So construct, what we mean by that is how the work is distributed between the threads. It's called a construct, work construct. So a for construct means I want to run a loop, but there will be a problem if I were to directly add a for loop inside of the pragma parallel clause. Why do you ask? Because every single thread will perform every single iteration. We don't want that. Of course, I want let's say one thread to perform one iteration, because otherwise I will have redundant data. So what does the for construct do? It allows for me to distribute the work among the threads when I'm using a for loop inside, when I want to use a for loop inside the pragma parallel. Okay, so let's move. So this is a static schedule. So what do I mean by static schedule? So first of all, let's go back to for construct. So for construct takes a few clauses with it. So this is the format, pragma for, and then there are a few clauses, as you can see. So schedule is one of the clauses. So what I'm exactly trying to achieve here, which schedule is that this is that how the work will be divided. This is what will specify how the work will pragma parallel generates the number of certain number of threads. Then there's for schedule static comma 2. So what will static do? It will assign one iteration, sorry, two, since I have written chunk size as 2. So it will assign 2 iterations to each thread, and it will be pre-assigned. When this statement is encountered, all of the threads will be pre-assigned some iterations according to their order. So we will have thread 0 will have 0 and 1, thread 1 will have 2 and 3, and so on. So this will be predefined at the start of the program, at the start of the block. So let's see a live demo of this. I'm currently logged into a HPC Param Rudra. I'm inside the login node and in the openmp programs directory. I have loaded up a few modules, Intel 1 API compilers, which is required for openmp. And this is the program that we will be compiling. It's the same one as in the PPT. So let's get to compiling it. G++. Okay, there must be some delay between the computer and the server. And then we have static scheduling.c. And I also need to add a connector to openmp. Okay, now the program is compiled. Let's see the output. So according to what I just explained, the output should be thread 0 will perform 0 and 1, thread 1 will perform 1 and 2, and so on. Let's see what the output is. Yeah, so thread 0 performed iteration 0 and 1, thread 1 performed 2 and 3, and why this happened? Why didn't 0 take 10 or 11, or if you ask some other number, why did 0 take some other number? That is because it is static scheduling. So it was predefined that this thread has to perform only these 2 iterations. So if I were to change the number, let's say do 3, and then see what the result is. Yes, I'll compile again and just run the program. So now 0 will do 3 iterations. So 0 has done 0, and then 1, and then 2. The output may be jumbled. That is because some threads are faster than the other, so they finish faster. That is why the output is jumbled. But now each thread is doing 3 iterations since I've changed the chunk size. That is it for this video. In the next video, we'll be talking about another clause of the for construct. Thank you, and do stay for the next one.